So in this video, we're going to look at an interaction model that kind of tries to explain what we saw in this last video, where in the first example, we had momentum being exchanged through an actual collision. You know, things touched each other and exchanged momentum like that. And in the second example, where everything seemed to happen at a distance, it wasn't really clear how the momentum was being transferred. We had this force acting, and there was this, the same kind of thing as above, where the particles moved in towards each other and then they moved away from each other. But it wasn't really clear how they were exchanging the momentum. It looks like this one's at a distance and this one isn't. And so, actually, the idea is that they're not so different after all. We say that the force in the second example was actually due to this exchange of virtual particles, which we call force carriers. The idea being that actually there is something going on here between the two of them, we just can't see it. And that's kind of the theme we're going to try and explore in this video. So what we're going to say is that all forces, these four fundamental forces we were talking about, gravity, electromagnetism, and the strong and weak nuclear forces, they all have an exchange particle associated with them. And clearly the exchange particle is just something they're going to use to exchange momentum, it's kind of in the name. And in this case of the electromagnetic force, it's just photons that we met before, remember? These wave packets. Turns out you can think of them as actual just particles, and in this case it's just an exchange particle for the electromagnetic force. And we're going to kind of diagram what that looks like in a second. So when charged particles interact, what they're really doing is just exchanging virtual photons, which are what transfer momentum between them. So the idea is that there's actually something going on here where they're exchanging particles with each other at each of these steps. Whenever they're experiencing this force, they're exchanging virtual photons with each other, and that's what's transferring the momentum. So here it's very clear, they hit each other, that's the exchange momentum. Here they're kind of passing momentum to each other through the emission and absorption of these virtual photons. And this is how they're exchanging momentum. So I've just diagrammed that on here. This is just, remember, that's our symbol for, that's actually our symbol for photons. Remember, that was our symbol for these gamma rays. That's the symbol we're going to use. And they're basically exchanging these little photons with each other at every point. And that's what's transferring the momentum between them and enabling them to have this momentum change that we see. So there is something going on. We're just not able to witness it. Luckily, there's a really helpful diagram we can use to actually see what's going on here that kind of really pares everything down to its essentials and makes it kind of clear for us to express what I was kind of trying to show here in a very simple diagrammatic way. And we call these Feynman diagrams, named after the famous physicist Richard Feynman who invented them. And so basically this is kind of what we see. So we see this is, first of all, the idea is to see that this is the direction of time. So what we haven't got here, and I'm going to mention that in a moment, is the path of the particles, right? This isn't actually an electron coming in like this and going off like that in space, because its path will be curved, right? We saw in this example that the electron has a curved path it's following. In this one, it's kind of a very straight in and then straight out, but this one, it's going to be curved.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.